SCAPE is an acronym for Stereoscopic Collaboration in an Augmented Projective Environment. It is an integrated platform that supports multimodal, collaborative interaction with a 3D dataset simultaneously in virtual and augmented environments. This platform is based on the visualization capabilities of the Head-Mounted Projective Display, or HMPD. SCAPE consists of multiple HMPDs, an augmented workbench, a multi-wall arc display, a set of unique interface devices called widgets, and a software framework. Core to this system's functionality is an HMPD prototype. This prototype, from the ultralight projection optics to the helmet itself, was custom designed and built in our lab, in collaboration with the ODA lab at the University of Central Florida. To detect the user's head position and orientation, the system employs a highball optical tracker from Third Tech. The tracker's LED array is installed on the ceiling. SCAPE employs an interactive workbench to support collaborative tasks requiring precise real virtual augmentation and manipulation. The workbench provides a surface area of 3 by 5 feet and is coated in a removable retro-reflective film from 3M Corporation. A custom-designed vision tracking system recognizes the two-dimensional position and orientation of real objects placed on the workbench. A four-walled display surrounds the workbench setup and is used for the viewing of a corresponding virtual environment, which may include life-size virtual models or walkthroughs. The wall display features rounded corners to improve image brightness, and a hinged retro-reflective door to ensure 360-degree horizontal immersion. The room measures 12 by 12 by 9 feet and is coated in the same film as the workbench. SCAPE integrates a set of unique augmented devices, or widgets, to facilitate interaction and collaboration. These may be shared among all users with ownership privileges. The magnifier widget is a framed handheld device that allows a user to examine a magnified area of arbitrary virtual data on the workbench. The cube widget is a handheld device coated in retroreflective film. It allows for selection and magnification of virtual objects from the immersive environment. It also provides an interface to textual data retrieved from these objects. The SCAPE software toolkit provides cross-platform high and medium-level control over all system components. It is run on 4 external computers. An SGI Octane performs rendering while PCs handle various tracking, vision, and networking tasks. In the Aztec Explorer application, an HMPD user sees a virtual map of an ancient city on the workbench. A virtual blue arrow denotes his current location in the city. Surrounding him is a 1-to-1 scale immersive walkthrough of this city. His virtual location resides at the position of his arrow avatar. SCAPE integrates the capability for multimodal navigation via head trackers, data gloves, and ID markers. To explore the local area, the user can physically walk around within the SCAPE room. The city is considerably larger than the physical area of the workspace. When approaching the physical extents of the SCAPE workspace, the user can make a hand gesture with a data glove to nudge his workspace forward. His movement occurs along the virtual line of sight, and the location of his workbench avatar is updated accordingly. Similarly, the workspace may be nudged backward. SCAPE allows multiple users to share the same physical workspace, yet to simultaneously explore disjoint areas of the virtual environment. The user may change his focus in the virtual world by placing an ID marker at a desired location on the virtual map. His arrow avatar is updated accordingly. The walkthrough view is translated to this position, and he may explore this new area of interest. A user may change his focus at any time. Local collaborators may do likewise. A simulated second user moves his workspace to the west side of the city. With the magnifier widget, a user can examine a portion of the city on the workbench without changing his virtual location. The images in the magnifier are rendered from a virtual camera associated with the walkthrough model itself and not the augmented map. A user can also share this data with collaborators, as the position and functionality of the magnifier and workbench remain fixed relative to each user. As a second mode of interaction, the cube widget allows the user to select a building from the immersive walkthrough by holding the cube in his virtual line of sight. The ancient structure is minified into the cube, and the user can then manipulate it like a 3D model in a transparent box. By toggling to text interface mode, he may access the information database stored with the object. He may scroll forward or backward through consecutive pages of text by rolling the cube. Each page consists of 3 faces, a primary display surface and 2 perpendicular auxiliary faces. On the left auxiliary face, he finds relevant footnotes and bibliographic information. On the right face, he finds diagrams, figures, and captions. As the cube remembers data queried by the user, it may be used as a method of information exchange with collaborators in other areas of the city. Aztec Explorer allows collaborators to examine and confer on an ancient, expansive city using multiple simultaneous modes of interaction in an augmented environment. Interior Designer presents the user with a 3D virtual floor plan of a dwelling on the workbench. Surrounding him is a 1:1 scale immersive walkthrough of the building. The user may decorate a room of the building by selecting real model furniture and placing it onto the 3D map. The furniture type and location are identified by the vision tracking system, and corresponding virtual models are added to the full-scale virtual room surrounding him. He may add, remove, and rearrange furniture at leisure, as these changes are reflected in the corresponding immersive walkthrough. In this way, the user can intuitively arrange the interior of a building, appreciating the results before physically moving large objects.